Okay, we're going to work on solving some quadratic equations. I know that's a big, scary math word, quadratic equation. We've certainly solved a lot of equations this year. Usually we say they're linear equations. Quadratic, why do we call it a quadratic equation? Observe what we have here. Sam, thanks for volunteering. You're right. It's because we have a power of 2 for my exponent, my highest power of my variable, instead of just a power of 1. If that were an x, whatever variable it is, if we just had a negative 5n or negative 5x without the squared, then we would call it a linear, not a quadratic equation. Okay, just to give you a little context. So we do have to deal with that squared eventually to unsquare our variable and solve for the variable. But let's just look at it as if it's any equation. What are we going to do? We're going to think the same thing we do for solving any basic equation. We're going to try to isolate our variable. First thing I'm going to do, I'm looking at the one on the left. Help me out. Okay, if you were thinking to get rid of the negative 5, I agree. Right now it's negative 5 times n squared. How do I get rid of the multiplication? Andrea, good. You said divide by negative 5. So I'm going to divide by negative 5 on both sides. The negative 5's cancel on the left side. And I'm left with n squared equals negative 240 divided by negative 5. Ryan's got it. Thanks, Ryan. Ryan's telling me that that is a 48. And that's sure looking a lot better to me. N squared equals 48. All I have to do is get rid of the power of 2. So you have to think to yourself, what's the opposite of squaring something? Opposite of squaring something. Charles, good. Charles said take the square root of both sides, and the square root and the square essentially cancel each other out. I'm left with n on the left equals radical 48. But we all know Miss Fisher would be extremely disappointed if she came back and all of your answers were left as radical 48, because that is no longer an acceptable answer. And don't even think about taking your calculator out and punching in your calculator. Instead, we are going to put it in simplest radical form. So we are going to divide by those magic numbers. Dom, help me out. Don't fall asleep. I know you're tired from snowboarding. Divide by those numbers. You know the numbers. 4, 9, 16, 25, all my perfect squares. Keep going. And you're going to tell me that that can be divided by 16. 16 times 3 is, in fact, 48. So square root of 16 comes out, and I'm going to get 4 radical 3 for my answer. I'm really close. I did everything right except for I missed one thing. Anybody see what I missed? It has to do with the fact that I took the square root in the problem. Let's go to a simpler example for a second. Okay, if we're looking at trying to get, instead of 48, which I know isn't a perfect square, let's just say that that was 49. Hey, that's really close to it, and that is a perfect square. Square root of 49 is 7. But how else could I get 49 by multiplying a number by itself? I know, it seems like a trick question. But somebody's going to tell me, hey, if I take negative 7 times negative 7, that also gives me a positive 49, right? Negative times negative is a positive. So anytime I put a square root into a problem, as I did right here to actually get rid of the square, right in this step, we actually have to put a plus or minus in front of the square root, indicating that there's a positive or negative, positive and negative answer. You actually have two answers. So down here at the bottom, I actually have a, that's a little bit hard to see, n equals positive and negative 4 radical 3. The other way you can write that, some people like to list it out separately and say, hey, we have a 4 radical 3. Whoops. A 4 radical 3 and a negative 4 radical 3, and just write them both separately. Okay, but the little plus or minus is kind of a convenient way of listing both of them without writing it out twice. Okay, second one. A little bit different here, just one more step involved. I've got an extra number term here if you look at it and compare to what we did in the first one. I've got this plus 7 that I'm going to have to deal with. Okay. Again, I tell you to ignore the power of 2. Just pretend it says 8n plus 7, or x if you like x better. And the first thing you're going to do to isolate your variable is think about it, pretend that the power of 2 isn't there. Okay, not all at once. You're all screaming in my ear. Get rid of the 7. Absolutely. We've got 8n squared equals negative 65 minus 7 is negative 72. Keep going. Now it looks a lot like what we started with before. We're going to divide by 8 on both sides to get rid of the 8. N squared equals negative 9. I like the way this one's shaping up. 9 is one of those nice perfect square numbers, right, Dom? So I've got to get the n by itself, and we're going to look back at what we did on the left, or we're going to recall that the square root, taking the square root is the opposite of squaring something. That cancels out, and I'm left with the lovely n on the left-hand side. And how do I take the square root of negative 9? What times itself will equal negative 9? And I'm debating between two answers right now. Is it 3 or negative 3? Okay, that's just my thoughts. Because I know 3 times 3 is, wait a second, 3 times 3 is 9. Does 3 times 3 ever equal negative 9? No, hopefully you're saying that doesn't make sense. So, it's not 3. Let's try negative 3. Negative 3 times negative 3 is positive 9. Because negative times negative is a positive. Can I ever get negative 9 by multiplying a number times itself? Good. Michaela's shaking her head saying, no, that's impossible. We can't ever get that. So what do we do at this point when we get to a negative number inside a square root? This might start to look familiar from algebra. Right, Matt? We're going to actually just put no solution. There are some quadratic equations that don't have a solution, and it happens when you have a negative inside the square root. So don't get freaked out if that happens. There are a couple on there, I believe, when you try them that are going to come out with a negative inside that square root. Okay, go ahead and try some, work through them. Good luck.